So today I am going to talk about a very important topic on how we are going to calculate the water required for horticulture and field crops. The flow of the meeting is going to be like this. First, we will look at what is evapotranspiration. Then we will see what are the climatic factors that affect crop water requirement. Then we will also see the reference crop evapotranspiration. Then let us look at the indicational seasonal crop water needs, and then the irrigation water needs. And also we look at the water requirement as per the different crop stages. And we have to understand another important concept called as crop factor. And finally, we will conclude with the water requirement calculation for a horticulture crop as well as for a field crop. So, and also I am just throwing open to the session that what is the way forward. If you want to learn more on water requirement, what is that you have to do. So now we all know that the evapotranspiration. So this is a very important term and all of you are aware of it. All plants have to undergo the photosynthesis activity. The plants suck water from the soil to live and grow. So here the main part of this, that water does not remain in the plant but escapes to the atmosphere when it is a sunny day, either through the plant's leaves or the stem. And this we all know is called as transpiration. And this happens mainly during the daytime. And just like how water will evaporate from an open surface, similarly, the same thing happens on the leaf surface. So you know that the leaves have small openings called stomata, and from the stomata, the water is going to evaporate. So the sum total of transpiration plus evaporation is known as evapotranspiration, which is actually an indirect way in which we are going to get the water required by the crop, because the crops will not be able to tell you how much water is required. So now let us look at the factors, particularly the climatic factors, and what are the other factors which are responsible and how we will have to calculate the water requirement. The first factor will be the climate. In a hot and sunny climate, the crops will require definitely more water than when the climate is cloudy and cool. And if you have a crop like rice or sugarcane, which is a water guzzling crop, they will definitely require more water than a crop like beans or wheat, which don't require that much water. And the growth stage will play a very important role. And the crops which are already grown will require more water than the crops that have just been planted. And another important factor will be the soil type. So whether the soil type is of a sandy type or a loamy type or a clayey type or a black cotton type, this will also have an important bearing on the water requirement of the crop. And finally, the spacing of the crop, whether it is a wide space crop or a closed space crop, that will be also an important factor to be considered. Generally, when we talk of water requirement, we are talking about the evapotranspiration and these important factors. And for example, we will tell vegetable requires 5 to 6 millimeters per day, or maize requires 4 to millimeters per day. So this is the kind of water that is evaporating. Whatever water is going out, the same water has to be taken back or given back directly to the root zone. Now, what this climatic factors, let us look at it in a little more detail. The climatic factors basically are sunshine and temperature. Sunshine and temperature play a very, very important role. You can understand that if it is a sunny and hot day or a hot climate, definitely the plant's evaporation and transpiration will be very high and it will require more amount of water. Similarly, if humidity and wind speed is very high, then also the water that is required will also be very important. So this water requirement, as we are seeing, is quite a complex phenomena. There are many factors like sunshine, temperature, humidity, and wind speed. So all these factors put together will affect the water requirement of the crop. Now the Food and Agricultural Organization, most of the material that I am showing to you is from the Food and Agricultural Organization, whom I consider have an authority in this area, and they have given certain very good classification. For example, the climatic factors are sunshine, temperature, humidity, and wind speed. And they have classified the crop water need either as high or as low. So if the highest crop water needs will be where when it is sunny, when it is hot, low, and windy. So obviously we can understand the areas which are very hot, dry, and windy, the crop water requirement will be very high. And the lowest crop water need will be when it is cool, when you have cloud cover, when the humidity is very high. So that time the crop water needs will be very low. So from that, what do we conclude? We conclude the same crop grown in different climatic zones will have different water needs. For example, if you have a maize crop which is grown in a cool climate, it may require only 4 millimeters per day on a particular day. whereas the same maize grown in a hotter climate may require anywhere up to 6 millimeters per day. So you can see how the climatic factors have a major influence on the water requirement of a crop. Now, in order to understand this in greater detail, the Food and Agricultural Organization has given that when we have to do this calculation, we have to take a standard or a reference crop. The standard or a reference crop is basically a grass surface. So as per the Food and Agricultural Organization, they have classified the climatic zones into desert or arid, semi-arid, sub-humid and humid. And based on the temperatures, they have classified if you have the mean temperature less than 15 degrees, it will be a low temperature. If it is between 15 to 25, it will be a medium temperature. And if it is more than 25 degrees, it will be a high temperature. So that, for example, let us take a standard grass crop. If it is growing in a semi-arid climate with a mean temperature of 20 degrees Celsius, will approximately require 6.5 because it is between 6 and 7. The average of 6 and 7 will be 6.5. But the same grass crop, if it is growing in a sub-humid climate where the evaporation will be between 7 and 8, then it will be about 7.5. So the higher the temperature, higher will be the evapotranspiration. Why do we need this reference crop? Because we can't calculate, because a grass surface is a totally covered area. So when we have to have a standard, we take it only from the grass surface as the standard, which is laid down by the FAO. So now you can understand. So it's like an open water surface and a grass surface, and the evaporating surface, the water is getting evaporated either by transpiration or evaporation from the surface. So the standard reference crop is grass. So based on this, this is a wonderful classification given by FAO, whereas you have to read it in the column wise. Now there are 5 columns over here. Column number 1 represents those crops like citrus, olives, grapes, where the water requirement will be 30% lesser than the water required for the standard grass. Standard grass is my reference. Similarly, if I come to column 2, crops like cucumber, radishes, squash, etc. will have only 10% lower than the water required for a standard grass. Crops like carrots, crucifers, lettuce, melons, and etc. they will have water as equal to the standard because the green coverage is fully there. So when the green coverage is fully equivalent to that of the grass, then that will be the standard. But in crops like barley, beans, maize, and some other crops, you will find the evaporation or the water requirement is much higher. So therefore, columns in crop number 4 and 5 will respectively require 10% and 20% more water than that is required in the peak period. So this is the classification, and based on your climatic region and based on the crop in consideration, you can look at this chart and actually you can decide what would be the kind of percentage that have to be taken into. So this is an indicative growing period. You know, like how a child grows, even the crop also grows. So the different crops, alfalfa is like basically the grass over here, banana, wheat, barley. So number of crops have been listed out. So not only the crop type also will have a major effect on the water that is required. So that is basically called as the seasonal water need. For example, let me take rice. Rice, some variety is a short growing variety having 90-day cycle, whereas another rice is having a growing cycle of 150 days. So a rice crop which is in the field of 150 days will definitely reach much more water than the rice crop which is grown only for 90 days. Of course, on a particular day, the daily peak water requirement may be the same. Maybe it is 7 mm in both the areas, but then the total quantum of water that you have to give for the crop will depend on the particular type of the variety of the rice crop that is in consideration. Similarly, the season also will play a very important role. So crops which are grown during the Rabi season or the crops which are grown during the Kharif season will also have substantially different water requirements. So basically this water requirement is a very complex phenomenon, and we are trying to understand how the FAO actually handles this. So now the growth stage also plays a very important role. Now I have taken the example of maize. A fully grown maize plant, definitely, as you understand, will require much more water than a maize crop which has just been planted. So here what happens, one very important point you need to understand, when the plants are young, evaporation will be more and transpiration will be less. And when the plants start growing, transpiration will overtake that of evaporation. This is the point that you have to understand from this particular slide. And you can see there are 4 distinctive stages. You have the establishment stage, you have the vegetative stage, you have the flowering stage, and the yield formation stage. So you'll be wondering why there is 90 to 130 days, because it depends on the maize variety. There are short growing, medium growing, and long growing varieties are there. As per that, accordingly, the different needs also will vary for the water requirement of the crop. So to understand this in a little more detail, during the planting and initial stages, evaporation is greater than that of transpiration, and therefore during the initial stages only 50% of the crop water need is actually required to be given. You don't need to give the entire quantity. So here comes the concept of irrigation scheduling. Like what we do in normal irrigation practice, we tell irrigate 2 hours continuously. That is not correct, because you have to irrigate as per the crop growth stage. Only during the crop development stage, this water requirement gradually will increase from 50% to the maximum crop water requirement of 100%. So that means when the crop development stage is there and when it coming into the mid-season stage, the water that is required is going to be the peak. In the late season stage, we have again a distinction given by FAO. What is that? Some crops like freshly harvested crops like cabbage, lettuce and all that, here the crop water need is right there right to the end till the end of the late season. As it was there in the mid-season, which is the highest water requirement. And these crops have to be harvested fresh and they should have a lot of water in them. So up to the last minute, you will have to continue to give water. But there are many dry harvested crops like cotton, maize, etc., which are maize for grain production. So here what will happen, the crop water needs that have to be given will be only 25% of the crop water that is required during the mid-season or peak period. So you will have to understand whether it is a freshly harvested crop or is it going to be a dry harvested crop. So you can see how the water requirement is also varying with the growth stages. Now to explain this in more detail, I've taken the example of a maize and we are looking at the 4 stages. We have the establishment stage, 15 to 25 days, vegetative stage, which is 25 to 40 days, the flowering stage, which varies from 15 to 20 days, yield formation and ripening is 45 to 60 days. The total growth period is 100 to 145 days. So now the water that has to be given for the evapotranspiration need of the crop will be split up, like 10% only you need of the total evaporation that is to be required, say 500 to 800 millimeter. Only 10% needs to be given during the establishment phase. About 30% will be in the vegetative phase, and the flowering stage will require the highest, which is around 50% of the water required. And during the yield formation and ripening, gradually we will taper down only to 10% of the water need. And along with this, you will have to consider one more point called as KC, that is the crop factor. And when the crops are young, you will have a lower crop factor. And as the crop peaks up, the crop factor can even go beyond 1, and then it will slowly fall down. It basically depends on the green cover of the crop. So to understand this, this is the total approximate values of seasonal crop needs for various crops, starting with alfalfa, that is the grass, our reference crop. And you will see the ones highlighted in yellow, banana, rice and sugarcane, they are the water guzzlers. You can see the kind of water required for the entire growing period. Like banana has 1200 to 2200 millimeters of water. Paddy also 1000 to 1500, and sugarcane between 1500 to 2500. These are all average values that have been taken. You could have values which are lower or even higher, but this is a good reference that has been given by the FAO. Now, crop factor, how are you going to determine the crop factor? Because this is a very important thing. We understood that there is an initial stage where almost the crop is going to cover about 10% of the ground. The crop development stage where you're going to have ground cover covering around 70 to 80%, and the mid-season stage where it is going to cover around 75%, and the late season stage where it is going to be tapered off. So when you are doing the calculation, you have to consider the crop factor. What stage of the growth the plant is in. So accordingly, the crop water requirement also will vary. So these are basically durations of various field crops which are given, broken up into the various stages. For example, the initial stage, the crop development stage, the mid-season stage, and late season stage. For example, you can take, I have just highlighted maize, for example. You have the total stage for the sweet variety of grace starting for 80 days, a short duration variety from 20 days right up to 20 days, 25 days, 25 and 10 days. And similarly, a slightly longer variety will be 110 days. And the various breakups of the initial crop development, mid-season and late season is already also mentioned. Continuing with the same chart, we have this chart very useful. I would urge all our viewers to go to the FAO website, and you can get a lot of information for every country, every region that is there, and all the various crop growing stages. The entire thing is given. So from this we can understand, you can see how the you will find most of the maximum water requirement is either in the crop development stage or preferably in the mid-season stage. So that is where the maximum water requirement happens. So then we also need to understand the crop factor. I told you the crop factor will depend on the growth stages. And for different crops, for example, millet, as I showed you earlier, the crop factor will be 0.7 during the crop development stage, and mid-season stage, it will be 1.9. Now you may ask me why it is 1.1. The foliage will cover even more than the canopy. So that is how this entire thing actually goes off. And therefore, you will find that the millets, the various stages are given below. Now, to summarize, we need to know the irrigation water needs. We have to consider one more factor. What is that factor? That factor is rainfall. So when there is a irrigation water need that needs to be calculated, we have the crop that requires the water due to evaporation and transpiration. We have to subtract the effective rainfall that is happening in that area to arrive at the irrigation water need. For example, this is a tomato crop which requires 786 millimeters in the total growing period in the absence of rainfall. If rainfall is there, then 68 millimeters reduced. So therefore, the net irrigation requirement will come to only 780 millimeters. So to summarize the entire water calculation, so here first we are trying to calculate the ETO, that is the climate and the reference crop put together will give us the reference crop evapotranspiration. That multiplied by the crop factor will give the ET of the crop. And then if you minus off the effective rainfall that is happening, you are going to get the actual irrigation water that is required for the crop. So this is the entire summary. So here it is the totally crystallized into a very simple chart. So now I will explain this entire process that we went through. You must be wondering what sir is going on talking so many complex terms. So let us make it simple. So I am just going to give you 4 examples on how we were going to do the calculation. Very simple. Let us now take mango. Mango has a spacing of 5 meter by 5 meter, and the place is Bangalore, and the evapotranspiration on a particular day was 6 millimeters. And the spacing being 5 meters by 5 meters, what is the crop area? 5 multiplied by 5 will give me 25 square meters. And the crop factor over here is being assumed to be 0.7. Generally, we assume 0.7 for wide space crop and 1 for a closed space crop. Now we have to understand how much percentage of the canopy. The canopy is the green cover of the tree. How much area is it covering in that spacing? So here in this, I am assuming that out of a 5 meter by 5 meter, the area that is getting covered is actually 4 meter by 4 meter. I'll just show you the thing. See here, this is the canopy. You have a 5 meter by 5 meter, out of which you are having a 4 meter by 4 meter area being covered. So what is the percentage of canopy factor? 4 into 4, 16, divided by 5 into 5, 25. So the canopy factor will be 64%. That means the crop is covering only an area of 64% of the 100% area. So going back to the calculation, now the canopy factor is 0.64. So the peak water requirement on that particular day is simply the product of the square meter of the area 25 multiplied by the evapotranspiration 6 multiplied by the crop factor 0.7 and multiplied by the canopy factor. It works out to 67 liters per plant per day. Now, if I take the same mango crop in a hotter place, so for example, Bagalkot, and the crop spacing over there is 8 meters by 8 meters, and I am assuming the same crop factor of 0.7, but the canopy factor which I am assuming over here is only 39%. Why is that? Here you can see in the second example, in this spacing has become over here 6 by 6, and this area is going to become, the spacing has changed as well as the area that is being covered. So the canopy factor will be 36 divided by a total area of 64. So therefore, so here the crop or the canopy factor will work out to 39% only. But even then, if you notice, when we multiply the spacing multiplied by the evapotranspiration of 7 millimeters by the crop factor and by the canopy factor, the water requirement works out to 122 liters. So what you understand from this particular slide is that when the spacing becomes larger and larger, the amount of water required by the crop will also be higher. So fruit crop generally, which is having a higher spacing, will definitely require more water, and how much canopy area that it is going to cover. So this is a calculation that can be easily done, and to make it more precise, you can even divide it by the efficiency of the irrigation system. For example, if you are using a drip irrigation system, you can take 67 divided by say 0.9. So accordingly, you may get around another 10% more, say around 70 to 75 liters more, for assuming that 10% loss is there. So this is how we can calculate with a very easy, simple method, which I call the ABCD formula. We just have to multiply the spacing multiplied by the evapotranspiration multiplied by the crop factor and canopy factor, and you will end up with the peak water requirement. Now, can we do this calculation for the field crop? Yes, it is very much possible, but the method is slightly different. Now, let us take a vegetable crop. The vegetable crop of 0.6 by 0.6, and the total area that I'm considering is 1 hectare, that is 10,000 square meters. And I am taking the evapotranspiration in Bangalore on a particular day is around 5 millimeters. Here, in case of vegetable crop, when the crop is fully covered, the crop factor will be 1 and the canopy factor also will be 1. And therefore, we have to calculate how many plants are going to be there. So that means we are going to have how many plants? We are going to have 10,000 divided by the spacing. You have attended my earlier webinar, you know how to calculate. Number of plants is equal to total area divided by spacing. You get 27,779 plants. And you know that you have to apply this water on a 5 into 10,000, that is 50,000 millimeters have to be applied divided by the total number of plants. So you're going to get 1.8 liters per plant. So this is the water requirement for a vegetable. Similarly, if I take sugarcane crop, which is again a 1 hectare crop, 10,000 square meters with an evapotranspiration of 6 millimeters and crop factor of 1 and canopy factor of 1. Again, you could calculate the number of plants. You will find it is around 13,889. And if you know that you are going to apply 6 millimeters over an area of 1 hectare, so 60,000 divided by 13,889, which is 4.32 liters. Now you must be wondering how this, you all know my earlier class that 1 liter, 1 mm is nothing but 1 liter per square meter. So based on that logic, so you're going to get around 4 liters is the water required by sugarcane. So these are the two methods by which we can calculate either by considering the number of plants and considering the crop factor and canopy factors, and very easily work out the water requirement. What is the way forward and how to learn more about crop water requirement? So this crop water requirement is a very big, it's a PhD subject, but I made it very simple. But then if you would like to further learn on how to do this calculations, there are very good free softwares available on the FAO website called CropPad and New Location. CropPad will give you the crop water requirement directly. And also if you are going to combine it with the free software like Local Climate, it has got all the meteorological stations across the world. You could choose the region, choose the place, and even go down to the local station and take all the parameters, and you will get all the rainfall, not only the rainfall, the wind, the humidity, all the climatic factors which I explained to you in the beginning. The entire thing will come in, it gets merged, and you will be able to work out the crop water requirement. Now, currently, you must have come across a lot of sensors in the field. A lot of people are using smart irrigation. So you have soil moisture sensors, you have tensiometers, you have digital type of tensiometers. So these are also very much useful in finding out what is the water requirement. And another area that is really becoming very popular now is the remote sensing application, and particularly the use of remote sensing data to estimate the water stress just by looking at the leaf color. So all you need to do is take your mobile, go to the leaf, and automatically when that photograph is sent to the cloud, the cloud will automatically analyze, and with having the data and the satellite remote sensing data, as the satellite circles around the earth, the data is and you will have an artificial intelligence package working, and then you will be able to work out exactly the water requirement that is required. And you will find that today a number of startup companies have developed very simple apps which can give you alerts on the soil moisture stress, and not only soil moisture, even nutrient stress. You can even look up even certain diseases that are happening. You will even have an advanced prediction model. And remote sensing technologies in combination with artificial intelligence, big data science, intelligent softwares, LoRaWAN technology. So you can have even wireless. You don't need to even be at that place. You can maybe have your farm 100 miles away, and you can be sitting over here and having the entire thing with a SCADA control. So smart irrigation also is becoming very, very popular. And in smart irrigation, we have the timer based, the volume based, and real-time sensor based. So these are all becoming very popular. So this way, this crop water requirement is a very vast subject, and I have simplified it to a very great extent for you to give an idea how exactly. If you want to precisely calculate, these softwares are available, and they're all free. Mind you, the advantage is they are very free, and you can directly go to the FAO website. Even the training modules are given. You just have to understand that and then do it. And there are many examples also. given. So thank you very much for the opportunity given. I just made it a very simple session. Sorry for
Thank you very much, sir. Thank you for a detailed and wonderful presentation. I will take up the questions from the participants now. The first question is, which horticulture crops are least water consuming?
So as I had shown you in my chart, so basically there are, for example, you have many crops like dragon fruit, you have varieties which don't have much coverage. So these are the kind of crops today where, because dragon fruit is a cactus. So like this, you have number of crops which are there, and you can actually, particularly the fruit crops that are there, and when the canopy is wide, you can definitely go in for these various. I think I've already shown it to you in the list.
Okay, I'll move on to the next one, sir.
Okay.
Do you think in the years ahead there will be more water scarcity for horticulture crops?
Yeah, scarcity of water is going to be the in thing. I mean, whether you like it or not, you know that most of the cities are already water stressed, and extraction of water is going at such an alarming rate that water tables which were say 300 feet have now gone to close to 800,000 feet. So water stress is going to increase, and on one side you have the population shooting up, and on the other side you have the water tables going down. So unless you adopt such micro irrigation techniques, and not just micro irrigation combined with precise irrigation water scheduling, what I told you, the exact crop water requirement, not trying to give entire quantity of water with the same constant time. You will have to vary your irrigation scheduling, and this with the help of computers can be done very easily, and many softwares are there, and many technology as it advances, definitely we will be able to overcome this challenge.
Okay. What are the latest irrigation technology available for horticulture crops?
So there are many things. For example, now you have the number of methods of planting also. You have the high value horticulture, you have the close spacing, you have many hybrid varieties, all combined here. Water management and nutrition management become very critical. And at the same time, not just irrigation management on a fixed basis, it should be a scheduled way. And at the same time, even based on what is the soil nutrient that is there, what is deficient, what is more, all that has to be analyzed, and it should be a totally integrated kind of package. And these days organic farming is becoming very popular, and organic, and so we talk of integrated farming. So all these will go a long way in the coming years to develop horticulture in a bigger way.
Okay, I'll move on to the next question, sir. What are your views about smart irrigation? Ability for smart irrigation, ability for the irrigation system to automatically decide when and how much water to irrigate?
Yeah, that is a very good question. Actually, smart irrigation today is in the nascent stage, as I can call it. In some countries, it is already developed. But the main challenge in smart irrigation today is these systems are available, but what is the affordability of this one? Number one is how big is the area? What we have seen, smart irrigation technologies become viable on a subscription model, number one, and in a model where the area is at least about 2 hectares, 5 acres and above. So then it becomes economically viable for the farmer to invest. And smart irrigation will be the way forward, because even the water that is being supplied at a fixed time basis is not correct. Like I remember in APMIP, one of the project directors told me, we should not land up doing flood irrigation through a drip irrigation system, which is what we are currently doing. We should not do that. We should do it on a proper irrigation scheduling based on the actual crop water needs. So that is where the role of a smart irrigation system comes into picture, wherein you are going to give the exact quantity of water required based on the various crop stages, and this will be decided by the soil moisture sensors or the tensiometers that are already placed in the ground, and that will exactly tell you, okay, should I irrigate now, or on a particular day if there is rainfall, I don't need to irrigate. So all this information with IoT based technology and a lot of things, a lot of good work is going on by the startup companies in the field and also by the major companies. We are also from Premier Irrigation doing this kind of work. So I think that is going to be the way ahead to use the water even more accurately.
Okay. In your company, what is the latest research and new irrigation product development going on?
Yeah, we are actually providing a lot of smart irrigation systems for both timer-based, sensor-based, and also volume-based to the farmers who are actually able to afford it, number one. Number two, we are also giving a lot of affordable and economical systems called drip irrigation kits and terrace garden kits, which can be used even for a 50 square meter or a 100 square meter area. We are providing these kind of kits. So these are another products. And in addition to that, we are the oldest sprinkler irrigation company in India, and we have a wide range of products that we will be able to provide to the farmers of the country.
Okay, I have completed the questions from our participants. We have many participants here, sir. I request the participants to, if you have any questions, you can unmute your mic and ask. We will wait for 2 minutes, sir.
Okay.
Or you can even post your questions in the chat window. I don't see any questions coming on, sir.
Okay.
They can get in touch with you if they require. Thank you very much, sir. On behalf of agricultureinformation.com, we like to thank Mr. S. Vijay Kumar for the talk and for answering the questions. I like to also thank all the participants in the meeting. This meeting will now be closed.
Thank you very much, madam.
You are welcome, sir. You are welcome, sir.
Thank you.
Thank you.
Thank you.